All right, so let's begin. So you want to start with logic gates, right? Anybody remember logic gates? Like some of the gates? No? None? Right, I pass around a list. Same rule as before. Put your name if you're already in the WhatsApp. If you're not in the WhatsApp, you put your number as well. Okay? So put your name and your number only if you're not in the WhatsApp group. If you're already in the WhatsApp group, well, let's put your name on. Right. So we need to remember, we need to redo something called logic gates. Right? So what's a logic gate? A logic gate is an electronic component, right? And it takes a binary, right? Binaries like ones and zeros. A one could be on or off or high, and a zero be like low. So it takes a binary input and gives you a binary output. Right? That's basically what a logic gate is. And the way the logic gate works, it works by something called a truth table. All right. So there are some. Right. There are some gates that we need to learn. Right. So the first gate that we need to learn is called a NOT gate. Right. NOT gate has a single input going into the shape represent the type of gate, right? Single input giving you a single output. So we need to learn when the input is 1 and 0, what the output will be. Right? When the input is 1, the output is 0. When the input is 0, the output is 1. This gate basically flips the input. So if the input is high, it gives you a low output. If the input is low, it gives you a high output. That's it. Okay? That's the first gate. It's called a NOT gate. Everybody clear with that? Yeah, that's all. So once you see this gate, 1 giving you a 0, 0 going to give you a 1. Copy down the first gate. It's called a NOT gate, right? I'm only working in binary. 1 and 0. That's only working. Right? That's the first gate there. That's gate number 1, a NOT gate. So once you see this symbol, you have to go in your brain and remember this truth table. This is called a truth table, right? I'm gonna make a note of it in case they ask you. To draw a truth table, I don't know where it is, right? Next one is an AND gate. And watch how it looks. straight curve, two inputs now, one output. That's the way it looks, right? So once you see that gate, that's an AND gate. Right? Let me give you the truth table for it. Right? I have a small question. Since we have two inputs, right? What could be a possible input? 0 here and 0 here, or what? 0 here and 1, or 1 here and a 1 and 1. We have four possible inputs. Right? You could have 1 and 1, 1 and 0, 0 and 1, 0 and 0. Right? Those are your possible inputs. You okay with that? Right? So remember it, 2 1s, 2 0s, 1 0 1 0. Right? I'll keep it as well. Right? So what would the output be? Keyword is AND. A 1 and a 1 giving you a 1, everything else is 0. Right? So that's the way to remember it. A 1 and a 1 giving you a 1, everything else gives an output of 0. Okay with that? You gotta learn it. But that's the way it's designed to work. It's designed to give you a 1 when you have two ones. Once you have a 0, you get back a 0. All right? A 0 will always give you back a 0. Next gate, we have an OR gate. Right? The OR is a little bit different. There's a curve back. So the straight, here's curve. And you have two inputs, one output.
Online.
Oh, you can only use like
These are exams.
all right, nice. So OR gate, right? These are the same inputs, right? We recognize same combination, right? And we can guess how the OR gate works. Handles, you must have two ones, but I think OR means you don't have to have two, right? You have a 1 or a 0, 0 or 1, you get a 1. So once you have a 1 on the input side, you always gonna get a 1. Two zeros will give you a 0. Right? That's the OR gate. We have two more gates to learn. Right? I'm gonna give you the input and output one time. Right. Anyway, I want to keep you thinking. Right? The NAND is the opposite of the AND. And the NOR is the opposite of the OR. You write it through table. The NAND is the opposite of the AND. These two behave in opposite ways. And the NOR opposite to the OR. I want you now to figure out what the output will look like. You can pencil in case you make a mistake. Right, they are opposite, right? So see if you can figure out what the NAND and the NOR look like. And NOR. So we can figure out it through table. If we can figure out what it should table for NAND and NOR will be. Anybody recognize by looking at these two diagrams? How is identify a NAND compared to AND? When you here? Yeah. Yeah. How is identify upside down? How is identify the difference between an and a NAND? Little bubble, right? That bubble. This here, the OR gate have it, the NOT gate have it too. It's called an inverter. So it flips everything. All right. So what I wanted you to figure out is what the outputs will look like. What will the outputs look like? Take 2 minutes. See if we can figure out what the outputs will look like. How many people doing labs here? I start on that a little bit earlier. Right? Let's see if it's correct. So the NAND is opposite to the AND. So 2 ones gave a 1. So now 2 ones will give a 0. 1 0 will give a 1. 0 1 will give you a 1. 0 0 will give you. Right? This is opposite to this. Right? Same thing here with the NOR. NOR is opposite here. 2 ones will give you a 0. This will give you a 0. This will give you a 0. This will give you a 1. That's okay? So now we have to learn all those games. Okay, and I want to show you how to apply them now. Copy it out and let's take a look at example one. How to figure out how to calculate a table. How to calculate a table. The example there is something called combination circuit. We put more than one logic gate together. So I want to show you how to use it, right? How to fill the table out. Take a picture. Online, you don't hear anything, right? All right, next, Daniel. Daniel, you will message in what time. Is that? This is message in somewhere. Finally, all right, so here's how it works. In order to figure out how it works, we need to know the type of gate, right? Inputs are A and B going into this gate. So what gate is that there? AND gate. And then that AND gate gives an output of C, which goes into a NOT gate. That's okay? So now A and B is for AND gate, right? So we're going back to AND gate and we're following the output. 1, 1 gives me a 1. 1, 0. 1, 0 gives me a 0. 0, 1 gives me a 0. 0, 0 gives me a 0. Okay with that? So by looking at this input, I can figure out the output. So I have to figure out what this input is connected into. That's okay? So this input A and B going into AND gate to give me C. How am I going to figure out D now? D is the output from a NOT gate where the input is C. So C going into a NOT gate to give me D. That's okay? So 1 into a NOT gate. If you look down there, 1 into a NOT gate is 0. Y'all seeing that? 0 into a NOT gate is, so looking at C alone and nothing else. C into a NOT gate gives me D. 1 into a NOT gate is 0. 0 into a NOT gate is 1. 0 into a NOT gate is 1. 0 into a NOT gate is 1. Everybody okay with that? Everybody okay with that? But again, this will only be easy to learn this off, right? So test on this next week, right? So let's do our next one, a little more complicated. Sometimes you'll end up with 3 and 4 logic gates. For now, I'll just give it a 3 and 4. Okay, so you have to figure out the gates and the input. That's okay? Copy it down. That's the first example. I'll give you the next one. By the way, anybody recognize what these two gates could be equivalent to? Those two gates are the same as one gate. What gate is that? NAND. These two gates behave just like a NAND gate. 0, 1, 1, 1. Okay, enough? So these two gates behave just like a NAND. Copy down. Let's try the next one. We call somebody in board. Hurry up. What is the name? Oh, there. So we call somebody on the board. Copy down. For now, otherwise I get to learn all the right? Ready? Let's go again. Try that there. Hmm? Yeah. This real plan. These logic gates are called control circuits, so you could use them based on the inputs to control like the AC. So you have a circuit. So for example, you want the place to be dark and you should press a button. When those two things happen, the AC should come on. So you have a lot of applications with it. Plenty topics. Plenty applications, I mean. Right, try number 2. Try number 2, figure out C and D by looking at the input. Here. Number 2. Try number 2. We did the number 3, right there. Number 2 there on the right and number 3 on the left. Good time. Okay, down to number 4 now. Right, let's check out number 2 first. Right, number 2. What type of gate is this? A NOR, and this is a NOT. That's okay. So 1 enter a NOR gate is 0. 1 0 is 0. 0 1 is 0. 0 0 is 1. But you okay with that? You okay with that? Yeah. And D is what? D is a NOT gate where the input is C. So looking at C, 1 gives 0, giving you 1. 0 giving you 1 1 0. You okay with that? Yeah. This one here, be careful. Right? Same thing, same principle, except watch. This input is the same thing going here. This input key is the same thing here. So here is also A and B. That's okay? And just add on one more gate. All right? Same principle. You have all the gates there to look at. Right? Same principle. Just understand that this A is being shared here and this B is being shared here. And C and D given here. Go ahead. Go ahead. Let's see what you come up with. Take your time. When you come on the board, come. Take your time, work out C. Figure out the type of gate you're coming from. Right, so work out C first, then work out D, and then use C and D to figure out. Online, still getting through. Right. Let me get some help. Let me start with Cupid. Cupid. Ooh, Cupid, I thought the first one. All right, Cupid, help me out here. What gate is this? AND gate, nice. So to figure out C, the input is in, correct? So help me out. 1, 0. Beautiful. You good to go. Let me see. Let me see. Right. It's Elijah. Apple white. Yeah, Elijah, help me out here. So D is from what gate? What gate is this here? Oh, nice. So A and B will give me. Then 1, then beautiful. E. Shakira. Oh, yes, Shakira. E. What does this say, Shakira? No, nice. So you're looking at C and D to give it E, right? So 1, 1 and NOR gate is 0, 1 is 0, 1 is 0, 0 is right. Does this behave like one gate? What y'all think? Blank out this 1, 1. What gate is that? It behaves like a what? These 3 gates behave like one gate. What it is? Like a no NAND, I mean, like a NAND. No, sorry, no, I know. I'm right here. Right? It behaves like a no. Nice. Let's see what the past equals look like now. Are you okay with that? Right, but you got to learn this, right? Yeah, okay. Let's see what the past equals look like. Online, are you okay? 9. Both 9s, are you okay? Now I know, listen. Right, first one is a table. They want you to fill the table out. So that's my please, let's fill it out. You're here online, Annalie? What can you yeah, okay. All right, probably listen. That's good. I'm good, let me know. Take it real quick. Perfect. Thank you. You don't have one. That's trying to get it. Together. Take time to say, I fill the truth table out first, right? Finish. What do you mean? What do you mean? Again, now one. One year. If it could be zero, we could be zero. I could be zero. Right? Like the question. You know, not validating. Right? But ideally, yes, they would already. I guess maybe. Right? So I like that. Oh, okay. But I think what it means. Alright, let's see how this went now. Let's see how this worked out. Everybody okay? Are you okay? Are you okay? Oh, we know the name soon, right? It's picking on yeah, still on this. Right? I think that's what I'm you. Maybe corner there, I don't know who's left. That it gets them right. 9 upside down that way. Get it in front. Sorry, that 9 star. See that? Right, and see that. Rahim was not the first name. First then. I'll pick an order. I'll pick a new first. First then. First one. What gate is that? That's not 10 that. You have a minute. But you don't put any means. Yeah, what gate is that? Not very good. Not gate. And it looks like this. If you go like COVID, that's what I do, no. First couple of months, I think it was picked out. And let me pick on Jaden. Next one. How you hand this look again? If you had this try, how to show it? Like that, sorry. And what's function? What's your explanation for the act? What's your explanation? Right. Everything else is zero, right? So you can say only. So you can write all that, right? So you can say produces a one only when you have 2 1. Okay. Everything else is 0. 2 1s give you a 1. Everything else is 0, right? That's okay. And then that, yeah, half an open good. Next question 4. It's 10. I try. Now, Pine. What's your explanation for the OR gates? Produces logic 1 with that one. Okay, I use the explanation for OR gates. Look at the OR gates. A 1 will always give you a 1. See that? If you have 2 zeros, you'll get 0. Okay? So once you have a 1 in the input, you're guaranteed to get a 1 in the output, right? And then the NAND gate is a right? So we were saying that explanation for NAND, I don't like it so much, right? For the NAND explanation, I would say 2 1s give us 0, everything else is a 1. Or 0 will always give you a 1. Okay? I don't really like this. That explanation is better for no gate. Alright, let's go again. Everybody okay with us? Let's go again. Cooperate. Try this one here. Part of the question missing, right? But sometimes they give you an application to this. And these are all year, I don't remember the year, right? But these are past equal. You know, see it? Ashton? Can I see it? Okay, I have no idea. I don't know the year. For your look back. But see it? I am just zoom up a little bit. Go ahead, have fun. right? But this is the application. I just can't find the next part of the question. Like things like this, you take a screenshot and that's right. Okay. Yeah, that's the screenshot. Just one more, and the more joy. All right, so this is the end of the electricity and electronics, right? After this, magnets. How do we do it next? To figure out W, 10x1. Double. How you figure out W? What's the input for the so let's look at W. Look at W going back to what game? No, going backwards. You're going back to not eight. Right, W comes on E. A and comes not A given W. What I can not get to figure out what W. Right, so and A to figure out W. And then A and B to figure out X. Right, so to figure out W, you're using the NOT gate and A. To figure out X, you're using A and B. To figure out Y, you're using W and B. Okay? Ready? Hurry up. Come on the board. All right, so let's go. W. Who's the play? Everyone pop their hand and do it. Yeah, no, yeah. All right, go ahead. The W is on a NOT gate where you're looking at A. Go ahead. Well, you see, now I won't call you again. Right, since that was easy, let's do X. Serena. X.
0, 0, 0, 1.
0, 0, 0, 1. So X is on AND gates, right? Where A and B are the inputs. Nice. 0, 0, 0, 1. Nice. Now pick on Ashton. Y. W and X into what gate? Can I gate this up? AND gate. Good. Tell me quick. Something wrong. W and X. Oh, sorry, W and P. Yeah, W and P. What's your wrong thing there? That's why. W and P. What you get? 10. You sure? P and W. Remember you're looking at W and P to figure out Y, right? 0, 0, 1. Right? 0. That's okay. 0, 1, 0, 0. Right? These gates have applications. That's sometimes this gate might be connected to an alarm. Right? And then A and B are conditions to turn on the alarm. I'm looking for one like it, but I don't see it. This is one, but the next part I'm missing. Right, copy down. Let's do our next one. This one came recently. You don't have to draw this one. I'll try and be here for this next one here, right? Jan 2017. Jan 2017, don't draw anything that's right the answer, right? So we start in here. Jan 2017, number 5. We're starting right here, right? Just write down the date. Really, you're not going to get easier 3 marks. 3 marks on that day. All right, first one is what? Not seconds and thirds. No, easy, right? Easy marks there. Next one. Fill out that truth table fast. Fill out that truth table fast. That's part P in it. Fill out the truth table. Fill out the truth table, and then we have one else to do on it. All right, let's see what you got. Let's see what you got. So 0 will give you 1, 1 give you 0. No 8, so that'll be 1, 0, 0, 0. That's okay. All here. Please don't learn this. Learn this input given you this. That's okay. Because look at that example. Instead of starting with 1, 1, they start with 0, 0. So it will be upside down, right? So don't learn this off, right? Learn what input will give you what particular output. All right. All right, let's go again. Last one, I'm done. sometimes, as you will see here, they have real life applications, right? So here we have to the gate, we have windows and we have doors. So basically, it's a security alarm. You'll see that? It's an alarm, right? You have two windows, you have two doors, and based on what happens, the alarm will go on or off, right? Right, the alarm will go on or off. So for example, if it's two windows closed and the two doors closed, the alarm off. You'll see that? Everybody okay with that? Now let's look at the intruder. The intruder tries to enter. Let's see if we can figure out what will happen. You don't have to draw it. Just write down what A is, what B is, and what C is. What A B? Look at the input and look at the gate. A will be equal to 1 because it's an OR gate, right? What would B be equal to? And then what kind of gate we have here for C? Oh, 1 0 in a OR gate is. So will the alarm be on or off? Right? Rope 1 is like high, so it'll turn it on. Okay? So if a burglar tries to open window 1, the alarm will go off.
Oh,
Huh? No, just a window. What would happen if you open a door? Would the alarm go off as well? Huh? Watch and see. Let's say you open a door here. That becomes a 1, right? So this will become a 1, and once you have a 1 in an OR gate, you'll still have a 1. Yeah, when you open it's a 1. When it closes, it's a 0. Are you okay with that? Yeah, so that's an application of it, right? Oh, they're packing up. Wait, that's not much. You can have a next part. We'll go out and we'll have it. Oh, yeah, all right. All right, so that.